In this video, we're going to be combining a bunch of strategies together because, again, sometimes just pulling out a greatest common factor is not enough, or just factoring by grouping is not enough. So that means it can be simplified again and again. The first time you tried to break it out, it wasn't simple enough. For example, in another video, I talked about how the number 12 can be factored into 3 times 4. This is factored, okay, for a number. However, it can continue to be factored even more. So 12 completely factored is the same as 3 times 2 times 2. So we had to factor it, but then we had to factor parts of it again. And these are equivalent numbers. This is just the whole, and this is broken up into its individual parts. So this is like factoring, and this is like foiling, like when you would go backwards, okay? All right, so when you're factoring completely, you have to get each term into their simplest form, which means they can't be broken down into anything other than prime numbers or lowest variables. So first you look for the greatest common factor so that you can simplify what you're starting with, and then you go on to your other methods that we've talked about in other videos. All right, so for example, I have this 3x cubed minus 15x squared minus 42x, and I say, good Lord, how am I going to find out what we started with in order to, what did we FOIL together or multiply together to get this polynomial? That's what factoring is. It's going backwards from having a whole polynomial and you're trying to figure out what you started with or what's its smallest part. So here I notice that a 3 will go into 3, 15, and 42. So I say, okay, I can divide each one of these by 3. Okay? And when I divide them by 3, I got to keep a hold of that 3 because there's no equals sign over here. I got to hold on to the 3, right? Because factoring just means I'm breaking it up into parts. For example, when I divided the 12 by the 3, I didn't throw the 3 away because 4 is not the same as 12. 3 times 4 is. So I had to keep the 3, all right? So here I notice that there's 3 x's, 2 x's, and 1 x. Well, if I have to take it out of every term, I can only take out what's the most in every term. Okay, so all 3 have to be divided by the exact same thing. So I can take out a 3 and an x. So if I divide this, I get x squared. I divide this, I get negative 5x. And if I divide this, I get negative 14. Okay, the x's cancel. People use that word cancel, but keep in mind that canceling sometimes means 1 and sometimes canceling means 0. Okay, so when you're adding negative 5 to positive 5, those cancel, we say, but they're giving us 0. But if I say 5 divided by 5, we say that those cancel, right? But it's really equal to 1. So be careful about that. That word's kind of overused. All right, so now I have 3x times all of this. And I say, great, I've factored it out. Well, we're not quite done. And the reason we're not quite done is because this polynomial can be factored even more. And we just did another video in 6.1 that talked about how to factor, or 6.2, how to factor polynomials where the leading coefficient is 1. So again, when we're factoring, we know that x times x will give us x squared. Now we just need to think about what times what will give us negative 14. They have to multiply because the last terms multiply to get the constant, period. Now we want something that multiplies to negative 14 but then adds up to negative 5, okay? So we have a couple of options. So when I think of negative 14, so I like negative 1 and positive 14, or negative 7 and positive 2, and there's some other combinations, 1 and negative 14, and 7 and negative 2. Okay, so these are some things that I multiply to get this. Now I know that my outside plus my inside have to equal the middle term. Okay, I know that because when I FOIL first, outside and inside end up adding up to be the middle term, and then the last is here. So if I add these two together, I'm going to get 13. That's not my middle term. If I add these, I get negative 13. If I add these, I get negative 5. Woohoo! Let's try that. Okay, so when you do that, you say, okay, I get positive 2 and negative 7. Those are the ones that I wanted to try. Okay, and you can do the negative 7 first and then the positive 2. It doesn't really matter. All right, so now I think I have it completely factored. Let's go ahead and check it using FOIL. So when you FOIL out the two binomials, you get these terms, and you can combine the like terms. Then you distribute, and if you'll notice, my final answer is the exact same as what I started with, and that is the goal. When you factor it out, again, it's supposed to be the same value as what you started with. It's just in simpler form. All right, let's look at using more than one strategy again. So try to find the greatest common factor here. We show that it's 2x. So factor a 2x out of this and this and this, and then factor your resulting polynomial even further. See if you can get the simplest form. Okay? Hopefully your work looks like this. Okay? So let's look at what happens if you do a greatest common factor, but it's negative, right? It's the same strategies we've been using, but those stinky little negatives, they really get you sometimes. They can really mess up a whole situation when you're trying to do math. So when it comes to anything with a negative number, then just be extra careful and go back and re-look at it to make sure that all of your negatives are accounted for. So here we have a leading coefficient that's negative. So if I'm going to factor something out of all of these terms, I'm going to go ahead and factor out the negative because I like for my polynomials to have positives in the front. Okay, so we're going to factor out a negative 16. Okay, and keep track of where those negatives come from. So if I divide this by a negative 16, I get a positive. If I divide this by a negative 16, I get a negative. If I divide a positive by a negative 16, then I also get a negative, right? So basically what we did was we divided this by negative 16, this by negative 16, and this by negative 16, okay? And then we got this, all right? Then we want to factor out this trinomial. What times what will give me t squared? Well, t and t. And what times what will give me negative 6? I have a couple of options, right? I can do negative 1 and 6, negative 2 and 3, 6 and, negative 6 and positive 1, and negative 3 and positive 2, right? It doesn't really matter the order of these. You can do 6 and negative 1. Just one of them's negative in each one of these scenarios. So when you try each one, you're saying, well, which, when I put in these various options for 6, I want something that the middle term gives me what my middle term is, which is negative 1. And we talked about that, okay? So it's trial and error. You have to kind of be patient with this because you're not always going to maybe choose the right combination the first time. So that's why you always, when you get your answer, always go back and FOIL it back out and check your answer. You don't have to write everything in detailed steps like this, but I would definitely, make notations on your paper just to confirm that you have the right answer. Because this is one of those situations where you can check to see if you got it right. And that makes it great because then you're guaranteed the right answer on your test. All right, so now it's your turn. So try. I'm just going to cover this up a little bit. Okay, so try this and then check your answer. Okay, so hopefully your answer looks a lot like this. You found that the greatest common factor was negative 2. And then when you factored out the negative 2, hopefully you kept track of your negatives. You got this polynomial, and then you had to kind of find various combinations of negative 14 so that you get your inside-outside correct. And then here's where I checked my work. All right.